Hi everyone, I hope you're all doing well today. Today's topic is focus and directrix, and our essential question is how can quadratics be represented in different ways? First of all, let's go over some vocabulary. A parabola is a plane curve which is mirror symmetrical and is approximately U-shaped. So similar to what you see here, it's a U-shaped curve and it's mirror symmetrical. Like for this one, the right and the left side are mirror of each other. And for this one, the up and the bottom side, the top and the bottom side are mirror of each other. Your parabola could face upward or downward. It could also face to the right side or face to the left side. All these are called parabolas. What is axis of symmetry? A line that divides a parabola into mirror images and passes through the vertex. First of all, what was vertex? If I have a parabola like this that opens upward, then the lowest point is going to be my vertex, like this point. If the parabola is facing upward, then the highest point is the vertex. If I have a parabola like this one, then the leftmost point is the vertex, or if it's opening to the left side, then the rightmost point is the vertex. Now, what is axis of symmetry? It's a line that passes through the vertex and divides into mirror images like this one. The left and the right side are mirror of each other. Or for this one, it's going to be a horizontal line like this one. This is my axis of symmetry. It divides it into mirror images, up and the top and the bottom one. Okay. Now, what is focus? Focus is a fixed point in the interior of a parabola such that the set of all points like x and y of the parabola are equidistant from the focus and directrix. And what is directrix? It's a fixed line perpendicular to the axis of symmetry such that the set of all points like x and y of the parabola are equidistant from the focus and directrix. So let's show them on this picture over here. Focus is a fixed point in the interior of the parabola. So it's going to be something like this, for example. This could be my focus. And directrix is a line which is perpendicular to the axis of symmetry. So if this is vertical, my directrix is going to be a horizontal line, something like this. Such that if I have a point on my graph like this one, for example, okay, then the distance between this point and the focus is the same as the distance between this point and the directrix. We know that if we have a point and a line and we want to find the distance between point and line, we need to draw a straight line such that we have a 90 degrees angle here. Okay, so this line and this line are equal to each other. If I consider any other point like this one, I'm going to have the same thing again here. Distance between this point and focus is the same as distance between this point and the directrix. So these two lines are equal to each other. If I have the parabola looking like this, opening to the right side, focus is going to be a point like this one in the inside of the curve, and the directrix is going to be a line perpendicular to the axis of symmetry. So it's going to be something like this. Okay, again, if I consider any point on my graph, on my parabola, the distance between this point and the focus is going to be the same as the distance between this point and the directrix. So these two are equal, or any other point is going to be the same again. These two lines are the same. Okay. Notice that focus is a point. That means we're going to show focus always with a coordinate plane ordered pair as x and y. And directrix is a line So always we need to use an equation to show the directrix, to represent the directrix. So if my parabola is facing upward or downward, then my directrix is going to be a horizontal line. And the equation of a horizontal line is always equal to y equal to something. This c is a constant number, y equal to something. If the parabola is facing to the right or left side, then directrix is a vertical line, and the equation is going to be like x equal to something. Okay, now what is p? P is a number that helps us find the focus and directrix. P is the distance from vertex to focus, or the distance from vertex to directrix. Let's show that here. The distance between focus to vertex, that's called P, or the distance between vertex and the directrix. That's also the same thing, it's called P. If my parabola looks like this, and then the distance between focus and vertex is P, distance between vertex and directrix is also called P. So that's P. Now let's see how does the equation look like in each case. If I have a parabola that opens upward like this one, let's see how we can find focus and directrix and the equation. We know that focus is going to be here inside the parabola, and directrix is always behind the parabola. So this is going to be my directrix, and this will be the focus. And I know that the vertex is going to be here. Vertex and focus are on the same line, and they are located on the axis of symmetry. And we know that vertex can be shown by h and k. We can use h and k. We call x and y value of the vertex as h and k. So this is my vertex, which is h and k. Also, I know that the distance between focus and vertex is called P. Distance between vertex and the directrix is also P. Okay, so now let's see. If I want to find the focus, I need to move from vertex P units to the upside, to the top, to reach to the focus. That means my x value is going to be the same because I'm moving vertically. The x is not going to change, but the y value will be added by p. So it's going to be h and k plus p. So just add p to the y value. How about the directrix? To find directrix, I'm going to move downward from the vertex to reach to the directrix. Now, again, directrix is a horizontal line, so it's going to be y equal to something. So we just need to find the y value of this point. I move down, so just subtract p from k. So it's going to be y equal to k minus p. How about the equation? That's going to look like x minus h squared equal to 4p y minus k. Notice that if your equation, your parabola opens upward, we're going to have x squared, and y is going to have only power of 1. I'm going to teach you a small trick to remember the equation of parabolas in these cases. So let's say I have a point here. I draw a horizontal line to the right and the left side, and it's going to cross the parabola at these points. This one could be x and y, the coordinates could be x and y, and this one could be negative x and y. Okay, so as you see, the y value is the same, but I have two different x values, positive x and negative x. So for one y, I have two x's, and the same is happening here. I have one y and two x's. So that could be the little trick to remember the equation. If the parabola opens downward, like this one, focus, vertex, which is h and k, and this is my directrix. And I move p up, and P down to reach to focus and directrix from vertex. Okay, so if I want to find the equation, the coordinates of focus, I'm just moving down P units. So only the Y value is going to change. H will be the same and the Y will become minus 2 because I'm moving down. And for directrix, I'm moving P units to the upside. So it's going to be Y equal to K plus P. The equation is going to be the same as this one, very similar to this one. And it's just going to be x minus h squared. This time I have negative 4p to show that my graph is facing downward. So it's basically reflected over the x-axis. So it's negative 4p times y minus k. Once again, this time, because I have 1y and 2 x's, x is squared, but y is to the power of 1. If the parabola opens to the right side, like this one, then let's say this is my focus, this is vertex, which is h and k, and this is the directrix. I need to move P to the right and P to the left from vertex to reach to focus and directrix. Okay, so to find the focus, I move P to the right side. This time the y value is not changing and only the x value is changing. I'm moving to the right. That means I'm just adding P to the x value. So it's going to be h plus P and k. That's the focus. Directrix, I'm moving P to the left side. Directrix is a vertical line here, so it's going to be x equal to something. And what is that something? Because I'm moving to the left, just subtract P from the h, and it's going to be h minus P. The equation will be y minus k squared equal to 4p times x minus h. So this time y is squared. Again, let's go to the same trick that we had here. So if I have a point here and I draw a line to the top and the bottom such that it crosses the curve at these 2 points, this point will be x and y, and this one will be x and negative y. So this time I have one x but 2 different y values. So I have 1x here and 2 y's. If the parabola opens to the left, again here I have focus, vertex which is at h and k, and the directrix is here. Okay. Okay, so if I move from vertex, P units to the left, I'm going to reach to the focus. So the x value is going to change at h minus P, but the y value will be the same. So this will be the focus point. For the directrix, it's going to be x equal to something, and because I'm moving to the right side, I'm adding to the x value, so h plus P. That will be the equation of the directrix. And the equation of the parabola will be y minus k squared equal to, this time again, I'm going to have a negative here because it's facing to the other side, the opposite side. So it's flipped or reflected over the y-axis this time. So I'm going to write a negative here to represent that reflection. Negative 4p times x minus h. So keep in mind that if your parabola is looking up or down, you're going to have x squared. If it's looking to the left or right side, left or right, then you're going to have y squared. Let's work on this example. Given the graph is given. Write the equation of the parabola and find all the critical values. So looking at this graph, I see a parabola that is opening downward. How do I find the vertex? That's going to be the highest point. This one will be the vertex. And where is it? It's at 0 and 0. I know that vertex is written as H and K. So I found H and K here. Where is focus? It's given here. It's at 0 and -5. Directrix is this line, which is always behind the curve, and it's given here as y equal to 5. Axis of symmetry is the line that passes through the vertex and divides into mirror images on the left and right side. The equation of this line is x equal to 0. Notice that if you want to write directrix and axis of symmetry, you need to write them in equation form. So if you just write 5, that's not acceptable. Or if you just write 0, again, that's not acceptable, because these are just numbers and doesn't represent, none of them represent a line. A line should be represented using an equation, not just a number. Okay, now what is the equation of this parabola? Let's go to the table that we have here. If the parabola is facing downward, then this will be the equation. So let's write that here. It's it's x minus h squared equal to -4 times pi times p y minus k. Okay, now let's just replace whatever we have here. We already have h and k, which is 0 and 0. So this will be x minus 0 squared equal to -4. I'm going to find the p later and write that here. This is y minus 0. Now, what is the p-value? That's the distance between focus and vertex, or vertex and directrix. So what is that? 1, 2, 3, 4, 5. Or here, 1, 2, 3, 4, 5. Okay. So p-value is 5. Notice that I'm ignoring the direction because I just need the distance. So when you want the distance, you're just gonna ignore the direction. So I don't care if this is going to the downward and going to the negative side. I'm just gonna take the value of the distance. So it's just 5 times 5. Now let's just start simplifying. X minus 0 squared is x squared. -4 times 5 is 20, and this will be y. So this is my equation. Now I'm going to write that in the standard form. We know that standard form is like y equal to x squared plus bx plus c. So we have y equal to something. So I'm going to divide both sides by -20 here in order to have the y by itself. So it's going to be y equal to -1/20 times x squared. So that's the equation in the standard form. Now, what is the domain? We know that for domain, we move from left to the right and look for the x value. So as I'm moving from left to the right, I see that all the x values are covered here. There's no restriction or nothing here, no limits. So domain is from -infinity to +infinity. Or I can write that as all real numbers. Range, we need to move bottom to top and look for the y values. So as I'm moving bottom to top, since I have arrows here, that means the graph is going to continue forever to the negative side or -infinity. So starts from -infinity. There's no restriction here on this side, but then my graph is going to end at this point, the highest point of that, which is at 0. The y value of this point is 0. And because 0 itself is included, I have a solid line here. And I'm going to use a bracket. So that's how we solve this problem. Let's go to the next one. In this example, we need to write the equation of the parabola with the following characteristics. Focus is at 4 and 0, and directrix is x equal to -4. So let's find them here. 4 and 0, this is my focus, and directrix is a line, and the equation is x equal to -4. So if this is x equal to -4, I'm going to draw a vertical line. X equal to something, that's a vertical line, equation of a vertical line. So I draw a vertical line here. That's my directrix. So I know that for sure my parabola is going to face to the right side because focus is always inside the parabola and the directrix is on the left side of that. Okay. Okay, now we need to find the vertex. I know that the vertex is going to be on the axis of symmetry because axis of symmetry is going to pass through the vertex and the focus. They're both on the same line. So I need to find the vertex. If the focus is at 4 and 0, I know that the axis of symmetry is going to be this line, and vertex is somewhere on this line. That means I know for sure the y value of the vertex is going to be 0. So that's the vertex. The y value will be the same thing. Now, what is the x value of that? I know that the distance between focus and vertex is p, and the distance between focus and the directrix is also p. Okay, so here we can learn that wherever is my vertex, whatever is this point, is going to be in the middle of these 2 points. So it's the midpoint of these two. So I'm just going to take the x value of this point and this point, which is 4 and -4, and divide that by 2. That will be the midpoint. So it's 0 divided by 2, and it's 0. So the x value of the vertex is also at 0, which is here. Now my graph is going to be something like this. Okay, I need to find one more thing, and that's the p-value. What is the p-value? This distance, 1, 2, 3, and 4. So that's the p-value. And also the other way, p is going to be 4. Once again, I ignore the direction, so I'm just going to write the p as a positive value. So p is 4. Now, what does the equation look like? It's facing to the right side, so this will be the equation. Now, I'm going to write that here. Y minus k squared is equal to 4p x minus h. Okay, now let's just replace whatever we have here. Y minus 0 squared, plus this is my h and this one is k, equal to 4 times p is 4 times 4 times x minus 0. Now let's just simplify that. Y squared is equal to 16 times x. Again, I just need to write this in the standard form. If your equation is looking to the left or right, now all we need to do is to write that as x equal to something. So I'm just going to divide both sides by 16. Then x will be 1 over 16 times y squared. So that's the equation of my parabola here. Next example here, we have the directrix given to us as y equal to -5. So I know that for sure this is a horizontal line. So if my directrix is a horizontal line, that means my parabola is going to face either upward or downward. And the focus is at 2 and 3. Okay, so let's find them here. Y equal to -5, 1, 2, 3, 4, 5. Okay, so directrix is going to be here. And the focus is at 2 and 3. Somewhere like this. Okay, so this is my focus, and this one is directrix. So I know that the parabola is going to look like this, facing upward, because I know that directrix is behind and focus is inside the parabola. Okay, now I need to find the vertex. I know that the vertex is passing through the axis of symmetry, and also focus is located on the vertex. I'm sorry, on the axis of symmetry. So it's going to be something like this. Whatever is my focus, which is 2 and 3 here, the vertex is going to have the same x value because they are both on the same line, on the same vertical line. So the vertex is going to be 2 and something. What is the y value? Once again, I know that the distance between vertex and focus is p, and this one also is p. So vertex is the midpoint of directrix, this point, and the focus. So I just need to find a midpoint. So just take the x, the y values. This time I'm going to take the y values 3, and the y of this one is -5. 3 and -5 divided by 2 will be -2 divided by 2, which is -1. So this is the y value of vertex. 2 and -1. So at 2 and -1, I'm going to have the vertex, and I know that the graph is going to be something like this. Now I need to find the p-value, the distance between focus and vertex, or this one. What is that? It's 1, 2, 3, and 4. If I count the other way again, 1, 2, 3, and 4. So P is 4. Now, because this is facing upward, this will be the equation. I'm going to write that x minus h squared equal to 4p y minus k. So let's start replacing the values here. X minus 2 squared is equal to 4 times p is 4 times y minus k is -1. Okay, now I'm going to start simplifying this equation. On the left side, I have x minus 2 squared. So I'm going to expand this first. X minus 2 squared is x minus 2 times itself. So I use the FOIL method to find this. So this is going to be x times x, x squared, x times -2, -2 times x, and -2 times -2. Then combine the like terms. It will be x squared minus 4x plus 4. So the left side is x squared minus 4x plus 4. And the right side I have 4 times 4, 16, and y minus -1 will be y plus 1. Now I just need to write this in the standard form. That means have the y by itself. Divide both sides by 16. Now I'm just going to separate the terms with the denominator that I have here in this way. X squared divided by 16. So each of these terms are going to be divided by 16. Minus 4x by 16 plus 4 divided by 16. And these two will cancel each other, and I will have y plus 1 on this side. Okay, and next I'm just gonna simplify these. 4 divided by 4 is 1, 16 divided by 4 is 4, 4 divided by 4, 1, and this one also will be 4. So the equation will look like x squared divided by 16 minus 1 over 4 times x plus 1 over 4 equal to y plus 1. And I'm going to subtract 1 from both sides because I want to have the y by itself. Now it will be, I'm going to write the y here on the left side and the rest here. X squared divided by 16 minus 1 over 4 times x, and 1 over 4 minus 1, combine these two. I'm adding two numbers that one of them is a fraction, so I'm going to put the denominator of 1. The common denominator between these two is 4. So multiply both by top and the bottom by 4. So this will be 1 over 4 minus 4 over 4. Now keep the bottom and combine the tops. 1 and negative 4 will be negative 3. So this is negative 3 over 4. And that's my equation. Okay, let's go to the next example. Okay, this time the problem is about satellite. We know that satellite looking is something like this. It's a parabola, and the receiver of the satellite should be in the middle, right in the inside of the satellite dish, and it's located on the focus of this parabola. So receiver is always on the focus. Now let's see. DirecTV is putting up a new TV satellite in Richardson. The satellite dish is in the shape of a parabola. The vertex of this parabolic shape is to be positioned in the pole such that is 6 feet above the roof surface. So let's say this is the roof surface. I draw the coordinate plane in a way that the x-axis is exactly on the roof and the y-axis is like in the middle where the satellite is located. It's passing through the vertex back basically. Okay, so now the vertex is 6 feet above the roof surface. That means it's going to be here at this point. That's the vertex. So I just draw the coordinate plane in a way that is passing through the vertex in this way. So this is the vertex. It's going to be at 0 and 6. X is 0, Y is 6 because it's 6 feet above the roof. The receiver is to be positioned 8 feet above the roof, and we know that the receiver is always located at the focus. Okay, so it's 8 feet above, so it's going to be somewhere like this, let's say. So this distance is 8, and that's my focus. It's at 0 and 8. Okay. Now we need to write an equation in standard form that best models the parabolic cross-section of this satellite dish. Okay, so first of all, I know that the parabola is looking upward, so this is going to be my equation. I need to find the vertex first, which is already here. That's my vertex. I'm going to write that here. Vertex is 0 and 6. And that's my H and K. Then I need to find the p-value. What is p-value? P is the distance between focus and vertex. So this is the p-value. What is the distance between them? It's 8 minus 6, which is 2. Notice that the directrix is not the roof surface. It's a horizontal line that is has 2 units down here. So it's going to be, let's say, for example, something like this. This will be my directrix here. Anyway, I found the p-value and it's equal to 2. Now let's start writing the equation. It's x minus h squared equal to 4p y minus k. X minus h is 0 equal to 4 times p is 2, y minus 6. So simplify that, it's going to be x squared equal to 8 y minus 6. Now we want to write that in the standard form. So divide both sides by 8 because we want to have the y by itself. So it's going to be y minus 6 equal to x squared divided by 8. Now add 6 to both sides. Oops. Okay, so this negative 6 and positive 6 cancel each other, and the equation will look like y equal to 1 over 8 x squared plus 6, and this will be the equation of my parabola. This was today's lesson. Make sure to write all the notes and attend tutorials if you need any help, or ask me if you have any questions. Have a great day.